Okay, hello, and please take out your notes. We're doing section 1.6, and we're going to be talking about angles. And so we have spoken about vocabulary, and we said the most basic pieces that we have learned about are going to be points, lines, and planes. And what we do with those is that we are going to be saying, let's put them together to make other shapes. And so we've done lines, and then we said, okay, let's take a line and let's take a piece of it, and we've done a segment. Well, today we're going to be taking a line and we're going to take a piece of it and talk about a ray. Now, if you've done your Delta Math, you've actually seen rays probably, okay? And if you've been outside, you've seen some rays. And so you know that if you've got a ray, it has a starting point and it goes forever in one direction. It's a portion of a line. Whereas a line goes infinitely in both directions, a ray has a starting point and it goes both directions. You know, a segment has two endpoints. So when you name a segment, as you guys know, you know that you're going to have between 2 points. And so if it's A and C, no matter how many points are in between it, to name this segment and to say, I specifically want it to be all the points between A and C, you have to say AC and put a segment above it. Okay, if you mean the line that goes forever in both directions, yeah, you can talk about AC that goes forever in both directions. Okay, so that's going to be the full line. This is going to be a segment or portion of that line. Today we're going to be looking at a ray, so you can get out your colors. An array has a starting point. We call it an endpoint. I feel like starting point makes more sense. But you look to say, okay, where's the dot, the endpoint of it? Okay, although there are multiple letters labeled on it, the one that must be spoken of is where it begins. Okay, on a segment, you know you've got both endpoints need to be spoken of. Okay, even if there's multiple points in between there, if you're talking about from A to C, you've got to mention both endpoints. On this one, you've got to say, okay, it starts at M. And which way does it go? So I always draw mine going to the right. No matter which way your item goes, I always put where it starts, the end point first, okay, and I put a dot over it, okay, and I say, okay, it goes forever in a certain direction, and all you have to do is mention the way it goes. So pick a point that you see on that in the direction that it goes and say, okay, if it starts at M, and then I could either pick O or N or O to put next to it. Okay, so I'm going to put N. And again, you could start with M and you're like, oh, let's talk about O. Okay, so you have to mention where it starts, or the end point, they call it. And then you have to pick any of the points in the direction of which it goes and signify that the end point, the starting point is at M. Put that dot above the M and then head off, and mention a letter along the way. Now, what you cannot do is you cannot start, talk about saying, hey, I'm going to start at N and go towards O. Okay, because that's not the end point. Okay, that's not going to be true. You also can't say, oh, I mean this picture over here, and as long as I have the right letters, then I'm going to be fine. So you couldn't do, MN works. NM would not be the same thing. Okay, that would start at N and go towards M in a certain way. Well, that's not what we're talking about over here. Okay, so those would not be good examples of writing down what we see on this picture to the right. Okay, so now we can build things together, and they're talking about opposite rays. So if you were in class with me, I would put my hands together and like make my thumbs go in opposite directions like a silly dance. And to talk about, we can have rays that go in opposite directions. And since I'm not with you, I'm sorry, but say that you have this, your starting point right here, J, and you say, okay, one ray is going to be J going towards K. Okay, I can draw that. And then I could also take another ray and I could say, well, it started at J here, and I could go towards H this way. And together they would form a line. Okay, the line HJ, or we could call it lots of different words. Okay, line L. And so, what would be an example of opposite rays? Well, we could talk about the ray JK, where it starts at J and goes towards K. And then what helps it form an entire ray? Well, we could say starting at J and then going towards H. Think about that for a minute. Okay, if you have J going to K, that's this blue ray to the right. And if I join that, add it to the ray JH, starting at J going towards H to the left, together they form, line L. Okay, and that's bad handwriting, but line L. So together, you can take opposite rays that are going to be collinear. And one thing we should talk about would be how many degrees are on a line. You're like, wait, a line is a line. It doesn't have any degrees. Well, no. Let's think about something for a second. If you have a circle, how many degrees does it take you to walk around a circle? You remember it's 360 degrees. So if you have how many degrees go around a circle, okay, walk around a circle, it's 360 degrees. To spin in a circle is 360 degrees. Well, if you just go halfway around a circle, you're going to go half of 360, which is 180. So when they're talking about an angle, you can see an angle right here. This looks smaller than 180 degrees. Well, the angle J, if you look at it, it's kind of like an open book that's kind of flat open. You could say angle J is 180 degrees. And it's weird to think a line, could be 180 degrees. But if you think about, if you open up an angle, far, like halfway open, like flat, like a book laying open on a desk, that's a 180 degree angle that you've got there. And so, speaking of angles, you can take two rays. Notice the ray XY. Okay. So if you take XY, oopsie, better get a marker. If I take the ray XY, starting at X going towards Y, and I take the ray XZ, starting at X and going towards Z, I can put those two rays together, where they have a common, end point or starting point, and together they can form an angle. And so we've got to talk about how would you name an angle? Okay, how would you name this angle? And the way you name an angle is you've got to use 3 letters, and the middle letter must be this common end point for the two rays. Okay, so you can walk around the angle in one, like a C. Okay, so you can go Y, X, Z to name it, or you could do Z, X, Y to name it. What do you mean, woman? Well, because it's a shape, we have to say either the word angle or use an angle. Everybody uses angle. It kind of looks like a less than sign, but the bottom of this less than sign is horizontal. Okay, so it says angle, and then you have to do 3 letters. The first letter can be a point on one of the rays, and so it could be Y. And then the middle one must be where the two rays meet. So it's X, and we call that the vertex. And then the third of the 3 points that you talk about is going to be Z. Now, also you could go backwards around the circle, and you could say angle Z. And I cross my Z's because otherwise they look like 2. So ZX, you don't have to, I don't care. ZXY. And so you have to have 3, and it tells you what you need to do for that. So you need to say, since it's a shape, it's going to have a ray on it, or it's going to have an angle measure or shown on it. Okay, so the sides of an angle are made with rays. Okay, and so we can talk about that here. So this is the vertex where the two rays meet. So one way to do this it could be called side AB, okay, or it could be called AC, or AC. Again, it starts at A, goes towards B or C, whichever one. This other one would be AD, starts at A, goes towards D, forever and ever and ever. Okay, so the angle that we could talk about here would be angle D, and then A, and then you could either say B or C. Okay, you could go backwards around it. You could do BAD or CAD, but again, the middle one has to be the vertex, the turning point on that angle. So the vertex is the common endpoint of the rays that form an angle. So this would be point A. Okay. So the rays that make those things are the sides of it. Okay, because they're how big it's going to be. So it's going to be AC would be one way to write it, and you can also do AD. All right. So we have different size angles, and we can measure them with a protractor, say how big are they? But common names of angles would be a right angle, and you can put a little box there. You've seen that with the Pythagorean theorem. And notice, if you're talking about angle A, you say it's here, whereas angle A is here. But if I say, what is the size of it? how big is it going to be? What is the measure of it? Okay, you wouldn't say length of the angle, you'd say the measure of it. Okay, so we measure angles in degrees. So the measure of angle A is going to be 90 degrees. Okay, you know that because of this. And so we call it a right angle. An acute angle, you've heard of acute angles. And acute angles are smaller than 90 degrees. So you put the big, so it's less than 90 degrees. It can't be equal to 90, but it's got to be greater than 0 degrees. A 0 degree angle is kind of weird. It doesn't actually, it's more like two rays smashed on top of each other. So an obtuse angle is going to be bigger than 90. So you say it's going to be greater than 90 degrees, but less than 180 degrees. Okay. And so we can call, remember, a straight angle is 180 degrees. Okay, so if you actually open up the angle all the way, so it's not a small angle, it's not a 90-degree angle, it's not obtuse, but if you actually open it all the way like a book, okay, it's going to be 180 degrees. And so, and then we're talking about the places of an angle. Okay, so let me get my highlighter out here. You might want to use your highlighter here. So the interior, interior is going to be inside of an angle. Okay, so this is the interior of an angle. Okay, interior is inside between the two rays. Okay, on the angle is going to be basically the two rays and the vertex that form it. Okay, on the angle. And then the exterior is going to be outside of the ray, or of the angle. Okay, so they're going to talk about, oh, this point is inside, this point is outside, etc. And so knowing like, hey, between the two rays in the inside is going to be the interior. Okay, so let's keep on moving. Let's see, we've got on side 2, congruent angles. Well, congruent means the same size and shape. Okay, so if you have angles that are congruent, well, they both have to be angles. Okay, same size, same shape, and their measurement has to be equal. Okay, so you might have two 30-degree angles. And so how you show that is that just like on like a triangle, how you're like, oh, this side matches this one over here, and this one right here matches this one over here. Well, one way to show this is to actually on the angle, draw like one tick mark. Okay, so that has a single. You could do two tick marks. Okay, and so this one matches this one right here. Another way, honestly, to show angles that are congruent would be this. Okay, if I see two angles, you could say, oh, you put like a mark like this to show that they match, or you could do like two like tube socks. You know how socks have stripes, and like think about Adidas. And so you've got two stripes, so those match, or you could do even like three and three. So whether you use like tick marks to show that they're the same size and they pair up with each other, or use like stripes, to show that they match, we can say, hey, they are congruent. And so how you would write this would be angle, okay, let's see, if we're saying QTR, notice I put the middle one is going to be the turning point. So if I say this angle right here, QTR, is congruent to angle, let's see, RTS. Let me see how you go around that one there. So yes, you could have done STR. You could have done, for the first one, you could have done RTQ. But if you're saying that two angles are congruent, you can show it by their markings. But if you want to write the statement that they're congruent, you say angle this is congruent to angle this. And so shapes can be congruent, just like segments can be congruent if they have the same size and shape. Two angles can be congruent if they're the same size and the same shape. Yeah, they're both angles and they both have the same size. All right, we're getting some more vocabulary, and then we're going to practice. An angle bisector is going to be a rare segment that chops things into two congruent angles. You're like, that's a lot of words. Stop talking. Okay, let's go with this. So first of all, take an angle. Okay, if you bisect something, okay, bi means two. Okay, sect means chop. Okay, so chop in two. So if you chop an angle in two, so an angle bisector is when something chops an angle into two congruent pieces. So if you have, once upon a time, there was a great big angle right here. Okay, do you see that big angle? It's obtuse. It's X, Y, Z. Okay, and then all of a sudden, once upon a time, came along a knife. Okay, this knife is going to be this ray right here. And this ray says, I'm going to chop you in half. Okay, it's like at the worst magic show. Okay, so the magic show people like chop. the fancy lady in half. And they're like, look, let's put her back together. She's not even hurt. So this ray takes the once upon a time, the big angle, and it chops it directly in half into two congruent pieces. So it bisects. So bi means two, sect means cut. So you've got the big angle, XYZ right here. And the ray, okay, the ray, YW is the knife that chops it into two congruent pieces. So they both are 80 degrees. And so that's a vocabulary that you should hold on to. So we need to practice answering some of these questions to say, okay, let's practice using our new knowledge and kind of saying, how does it work together? Okay, so we built the basis, and now we're going to say, can we use this? So now it says, name the angles, all of them that have B as a vertex. Okay, so let's find B. Okay, she's right here. Oopsie, I need to use a marker. Otherwise you can't see it. So let's see. This is angle B right here. Okay. And angle B, and notice those numbers there. Okay. The numbers are not the size of them. Okay. So this is not 6 degrees or 7 degrees or 5 degrees. What they're talking about is going to be the measure of the angle that the number is inside. Okay. So what are you talking about? There are two ways to name angles. Okay, one is going to be using 3 letters, and then again, math teachers, students, etc., don't like to write a lot of words, and it takes a long time to name an angle. So a shortcut can sometimes be used. So if you're talking about this angle right here, okay, the angle ABD. Okay, so let's talk about this. If you're talking about the angle ABD, angle ABD. Okay, so that's from here to here to here. That works. Okay, notice B is the turning point. ABD, you can talk by the 3 points, but a shortcut for talking about the angle ABD, the angle that's inside of that, okay, is going to be right here, angle 7. So those are going to be synonyms that say, I can mention ABD or I can say angle 7, and either way I'm talking about this angle that's inside of angle ABD. Okay, so it kind of makes like a C to hold in its little cup hand the angle that you're talking about. So again, you could talk about DBE right here, or you could say angle 6, angle DBE or angle 6. Those are synonyms as well. Okay, so ponder that for a second. ABD is equal to angle 7. Okay, so again, there's always a shortcut. Just like if we're like, we can name a line by 2 points, line AB, or you could say it's line L. So there's a shortcut sometimes if you have a number that's kind of sitting within the cup of that angle. Okay, so angles make like a C. And so if there's a number within there, you can use the shortcut. So let's name, I'm going to erase some of these things so they're kind of off here. Okay, so let's do this. Let's erase this. And let's go back to the start of it. So if we're talking about what are the angles that have B as a vertex? Well, B has a vertex. We can name them shortcut or long cut. Okay, so let's talk about it. Let's talk about this one right here. Okay, and you could name that as angle GBE. GBE. Can you see a shortcut of how you can name GBE? So GBE makes this kind of L, or you could call it angle 5. Okay, so that's one option. You could talk about EBD, okay, or you could name it angle 6. Okay, kind of weird. Let's see, we could do ABD. Okay, so ABD or angle 7. Okay, that's over here. And then the top one, there really isn't a shortcut. Okay, so we're going to call that one angle GBA. Could you call it ABG? Yes. Okay, but B has to be in the middle. Of all the ones that have B as a vertex, B must be in the middle. Okay, and so I want you guys to be comfortable with that. What are the sides of angle 5? Okay, so let's look at angle 5. Angle 5 is this blue angle over here. So angle 5 is here. The sides are 2 rays that meet at B. So they're going to be B going towards G. That's the ray that forms the top of it. Okay, the top of this is BG. The bottom, the other side of it is going to be B going towards E or F. It doesn't matter which one you do. So starting at B going towards E or F. So write E or F, starting at B going towards E or F. Okay, so the two rays that form an angle are going to be the sides of it. Okay, give me another name for angle 6. Okay, angle 6 is this red one here. Angle 6. Think about it for a second. And if you were in class with me, I'd be like calling somebody, I'd be like, okay, what would you do? And I would say, hey, check with your neighbor. Okay, so angle 6 is going to be angle EBD. What else could I say? Angle DBE. Okay, so you've got to go around there. Okay, could you do FBD? Yeah. Okay, any of the points on one side, the middle where it turns, the B, and then D. So absolutely. Okay, so then name a point that's on the exterior of angle ABD. So let's find angle ABD. So here's ABD. Okay, the interior is right here. Okay, so I say, give me a point that's on the interior. You could put a point right here, like point Q. Okay, so that's kind of in the C of that angle. Okay, but it says, give me one that is going to be on the exterior of it. Okay, outside of it. So do you see one that's not within this little fold here? Okay, not within the little yard of angle ABD. Well, you could say angle E, or point E, point F, point G. Any point that is not within that cute little C yard of the interior of that angle. Okay, between the two rays, between the two sides of it. So you could write point E, you could write point F, but just not any of those guys there. All right, so let's classify these things. So it says go to MJK. So remember, you start at a point, a ray. So you go to J, turn a corner, and you go to K. Okay, what do you think that's going to be? Well, it's going to be 90. Why? Well, the straight line here is 180, and notice on this side, this is 180 as well, or is 90 degrees. So if the whole open book is 180 degrees and this is 90, this must be 90 as well, because 90 and 90 make 180. So this has got to be 90 degrees. So we're going to call it a right angle. Okay, so new picture. How about angle LJP? So L to J to P. Well, it's bigger than 90 degrees because this is 90 right here. So it's going to be obtuse. Okay, and then the last one here is going to be MJN. So MJN, that's right here. So this angle formed is going to be acute. Okay, so knowing their words is going to be helpful. Okay, next part. If the measure of angle ADC is 115 degrees, the measure of ADB is 3x plus 12, the measure of BDC, okay, that's a lot of words. You're like, what is going on here? Well, let's just take it in bite-sized pieces. Okay, so let's record what we know. Okay, so, no, it's not time to go home, but I'm recording this video between classes. So if you look at the measure of ADC, so ADC goes from A to D to C. So let's color this. So A to D to C. So this angle right here, the blue angle, is 115 degrees. Okay, so let's mark it. So the next one is going to be ADB. Okay, so where's ADB? So A to D to B is going to be 3x plus 12. Okay. So this our angle right here is 3x plus 12, okay? And then BDC, you're like, where's that? Okay, well, look at this. So B to D to C is going to be 4x minus 2, okay? So it's like, how would you even do this? Well, just like if you add up two segments, okay, they equal the whole. So if you add up the part plus the part, and it equals the whole. So you can do the same thing with angles. Okay, so just like with segments, if you add up the two parts, you get the total. So if you add up this one plus this one, you get the total. So with angles, if you add up the two parts, you equal the whole. So it's a little weird. So you got to, pause this and think about it if you need to. Like if you know the two pieces are the pink, the red and the green, the total is 115 degrees, you can write an equation and solve it. So again, we're taking a visual and saying, all right, the sum of the parts equals the whole. We'll take 3x plus 12 and plus it to 4x minus 2, and you equal the total, which is 115 degrees. Okay, it's a little weird for your cute brains to be like, what are we doing? We're adding angles. Well, it's the same thing as anything else. If you add up the two pieces, you get the total. So combine like terms, you get 7x plus 10 equals 115. Subtract 10 from both sides. You get 7x is equal to, how much is that? 105. Divide both sides by 7, and you're going to get x is equal to 15. Okay. Now, I may ask you, oh, what's the measure of this angle right here? And you'd be like, okay, we'll plug in x is 15 and get the answer. So you do 4 times 15 and subtract 2. So that's going to be what? 30, 60 minus 2. That'd be 58 degrees. And if you found the red one, I'm sure that these two, the green one and the red one, should make 115 degrees total. So I may ask you to solve for x, or I may say, okay, once you solve for x, do it. So if you got to be real careful to label what pieces you know. Okay, so the next thing is we got to actually draw it first, okay, and then do it. You're like, oh dear heavens. So let's draw it. So Z is in the interior of this angle. You're like, okay, I quit. I'm going home. Okay. So we have to draw Z inside of this angle. Well, if you want to draw something inside something, let's draw the angle first. So let's do WXY. So angle WXY, draw it obtuse. I don't know what it is, but it doesn't matter. Okay. So W is on one of the sides. X has to be the vertex, and then Y is on the other side. Okay. So WXY. So the turning point is at X. The vertex is at X. Okay. And they say, hey, the measurement of WXY is going to be 5x minus 58. So WXY, this angle is going to equal 5x minus 58. Okay. Now we forgot something. They say point Z is on the interior of that angle. Okay. Interior is kind of within that C. So if you've got the C WXY, Z's got to be inside here. So you put Z inside here. Okay. Z. Hello. Now, they're going to use it to connect it to make 2 more rays, okay? They don't say that it bisects. So it's a knife that chops these into pieces, but they don't know that it bisects it into 2 congruent angles. So that angle, that ray XZ is going to be making 2 more angles out of the bigger angle, okay? So we're chopping it up, not necessarily in half. So let's read the next part. It says the measure of YXZ, okay, is x plus 1. So YXZ is x plus 1. So this is x plus 1, okay? And so that goes from here to here to here. And then they say the measure of WXZ. So, I didn't read this. Let's rewind. Okay, sorry. Go back. Let me erase this. Okay, got to read your letters correctly. Because you're going to put things in the wrong spot. Okay, so let's try it again. It says YXZ. So where's YXZ? Okay, YXZ, it looks like it's on the bottom. Okay, so let's try that again. Down here. YXZ is going to be down here, and that's going to be x plus 1. Okay, and the other one that they did talk about is WXZ. So where's WXZ? Let's start at W, go to X, and then go to Z. That angle, okay, within that C that they make, WXZ is going to be 2x. Okay, and so you've got to kind of hear like, hey, there's a big angle, then there's a point Z in it, and that point Z is you can make a ray to be a bisector of the bigger angle, and then you label what you know. Try to read the letters, right? And so, like I didn't. And so we're going to say, okay, the sum of these parts, so this little angle plus this little angle make the total angle right here. So you got 2x plus x plus 1. And their total is 5x minus 58. Pause a second. Do you see how if you plus up the 2 baby angles, they equal the total? And so there's a big step here, okay? So if you ever want to watch this video again, I will attach it to Student View in the gradebook, and you can click on that link that you see on this lesson, and you should be able to rewatch this. So let's solve this by combining like terms. You get 3x plus 1. Even if you want to just watch this problem again, you can do that too. Or watch it with your mama or papa, or your brother, or whoever you want to. So let's solve this. And so we minus 3x from both sides. So 1 equals 2x minus 58. Ooh, this is tricky. So I got x's to one side. I'm going to get the numbers to the other side. Okay. And I'm going to get 2x is equal to 57. Good heavens. Oh, 2x. Dang it. Let me erase this. I don't know what I was thinking. This eraser takes a long time to do. Okay, so this is equal to 57. Divide both sides by 2, and you get x is equal to a decimal, which, okay, fine, 29.5. So x is 29.5, and they said, hey, could you use that to find yxc? So where's yxc? Okay, let's move this over. So yxc, okay, yxc, that's the bottom. Okay, so that says to get yxc is in the up here. Yxc is x plus 1. So you take x and you add 1. Well, then 29.5 plus 1 would be 30.5. And that's going to be degrees because it's an angle. And so that's how many degrees that bottom angle is going to be. So that's definitely like getting feisty, towards what we've got. I like the bottom one. And I'm going to scooch this up so you guys can see it. And if you want to pause the video and say, hey, try this a minute, you can do that. If you want me just to walk you through it, I can do that too. If you've got the measure of AEB, so where's AEB? So AEB, that is going to be 6x plus 1. So the angle formed by AEB, E is going to be the vertex, is going to be 6x plus 1, and then CED, so CED, okay, that's over here, CED is going to be x plus 9. And then they say that DEB, 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 pause a second. Let me think about this. I think I botched something. AEB is 6x plus 1. CED is x plus 9. Okay. Oh, you know what? If you don't read what's up here, you're going to struggle, okay? Okay, we're supposed to find the measure of DEB, okay, DEB. So DEB, we're supposed to find this, but it doesn't appear like that seems like a hard question, okay? So let's read the problem above, okay? The problem above says, hey, guess what? EA and ED are opposite rays. Okay, that means that if you draw this right here and you join it to drawing this ray over here, they're opposite rays. That means they make a straight line. Okay, then the part I didn't read was this. EB bisects AEC. What do you mean, woman? Well, look at AEC. Okay, so you see AEC, that's this right here. And B chops it in half. Okay, the ray EB chops this bigger angle right here in half. So if something's chopped in half, well, then that means the two pieces are equal or congruent. So this means this is 6x plus 1 as well. So, and then the next, so that would be the thing that if you don't read that, you're not going to be able to do the question. You're like, oh, it's bisect. So that means, oh, it's bi means 2, sex means chopped. It's chopped into 2 pieces. So let's add up all 3 parts. You do 6x plus 1, and you add it to 6x plus 1, and then you add it to x plus 9, and this is a straight angle. And so it equals 180 degrees. So if you add up all these things, you're going to get, combine like terms, you get 13x plus 11 is equal to 180. Minus 11 from both sides, you get 13x is equal to 169. So that means x is equal to 13. And then you can find any of these angles. Okay, so you could find this angle right here. So you go 6 times 13 plus 1, and I might need to use a calculator for this one. 6 times 13, and then add 1. I'm going to grab it on my phone. Okay, 6 times 13 is going to be 78. Plus 1 is 79, so that's 79 degrees here. That means this right here is 79 degrees as well. And then if you take x plus 9, okay, you're going to take 13 plus 9, and you're going to get 22 here. So each of the 3 angles, if you want to find this overall angle here, you just add these 2 together, 79 plus 22. And you're going to get 101 degrees. I don't know why my marker's not working. But that's going to be the total angle. So the last 2 questions are kind of big, but I would say do your best when I ask you to do these questions. All right, thank you so much. Have a good day.